Hi everyone. So welcome to the second virtual meetup for the Tensorflow and Deep Learning Malaysia group. So today we are happy to have Dixon Neo, who is currently working as an academician at University Tenaga Nasional, UNITEN, where he specialized in robotics, time series, and computer vision modeling. So his current interest is in practical deep learning application and deployment. So he has over 9+ years of modeling deep learning based time series and also computer vision algorithm. And he has about 3+ years helping companies deploy DL deep learning model into production, and also 10+ years of academic journal and conference publication. So without further ado, so I pass the floor to Dixon. So Dixon, you can start your presentation.
All right. Hello, everyone. Can you guys hear me? Because usually when I say something, there's echo. So let me know if there's echo.
No, we can hear you fine. No echo.
All right, cool. Let me just share my screen real quick.
Nego. Hah? Okay lah. Dia suka happy kan?
Okay.
Yeah, so I request all the participants, if you're not asking questions, please turn off your mic. Thank you.
Okay, wait, let me just do a final adjustment to the screen position. Cool. Can everyone see my screen already?
Yep.
It's showing full screen, right? Okay.
Yep.
Yeah. Okay, let's start. Hey, hello everyone. My name is Dixon, just as Dr. Pur has introduced just now. So me and him, we're an old. I think we knew each other from a couple of years ago. Haven't seen you for a long time. You lost a lot of weight. Wow, and I'm just so delighted to be here today to share with you on some of the few things that I know and I learned as I have been in the field for a couple of years right now. So as you know, I'm an academic, so I teach at University Tenaga Nasional, UNITEN, and I've been teaching for about six years right now. And prior to that, I was actually a student, and my research in deep learning actually started way before that. I think in 2012 or something. So back then it was still in the very early stages of deep learning. There wasn't any TensorFlow, there wasn't PyTorch, there wasn't like a lot of things that we conveniently use today. That it wasn't there, and today we have so many things. And so my research interest has always been robotics. So I do a lot of hardware robotics, and I do electronics side of robotics most of the time. And also during my student years, my graduate student years, my master's and PhD, I also got myself involved in using deep learning for time series as well as a computer vision problem. So that's what I do officially. So unofficially, during my free time, I am a big fan of open source. So I contribute to open source code after my working hours or when I have time. So I'm right now a core developer of this open source project called IceVision. I'm not sure if you've heard about it. IceVision is a computer vision framework, and I'll talk about it after this in my slides. And it's super easy to use, especially if you have you're not familiar yet with deep learning and computer vision. Like, I highly encourage you to try it. So yeah, I call myself a developer advocate, not as a formal position, but as an informal position, because I like to advocate for open source stuff. And I now write actively on my website, dixonneo.com. So if you have some time, just feel free to check out some of the blogs that I wrote. Okay, so today my talk will be revolving around deep learning. Yes, But I won't be covering like a lot of the basic. I wasn't expecting I didn't anticipate the background of the audience very well for this talk. I thought that you guys had already some good background, but it's okay. I will try to tailor this presentation, this talk, to the best of my ability to everyone. So if you have any kind of questions throughout my presentation, just feel free to raise your hand or something, and then I'll be happy to answer your question. So my presentation today will talk about deep learning, but I will talk more about the application side of deep learning. And I'll talk a little bit about a few of my recent projects and what are the tools that I use to apply the things that I model using deep learning and apply it into like a real world problem. Right, that's a long introduction. Let's get into it already. All right, that's about me. Okay, I've just talked about this. Cool. Here is the content of my presentation. So I'll tell a little bit how I got started and how I got started in my journey of deep learning, and what are the gaps that I see at the current in the current deep learning field. And we'll talk a little bit about that. I promise it's not going to be like a theoretical thing. And at the end of midway through the presentation, I'll talk about two of my recent projects, which involves cloud deployment of deep learning model and edge deployment of deep learning model. So if you're familiar with deep learning already, this should look pretty simple to you. I'm just going to talk a little bit about what I did, and maybe you too can try it to use that project in your next upcoming projects after this. Cool. So a little bit more about me. So right now I am in my 10th year in this deep learning field already. So during this 10 years time, I've published a lot of paper, a lot of publication in deep learning. I'm not here to brag, but I'm just here to give you a sense of how I'm in this field for some time already. And yep, being an academic, I was told that as a lecturer, like in academic, paper is priority. Like paper means publication, right? So in anything that you do, the number one priority would be publication, publication, publication. That is what we see in academic, in university, in research institution. And in academic, it is most of the time, it's more about how attractive your paper is. In other words, we like to use this word called novelty, how novel that paper is, how new that paper is. And that's we spend a lot of time justifying, oh, this thing is new, this paper is good, and so on and so forth. And we are judged based on the paper that we produce. And like whenever we apply for grants or promotions, and the first question that usually comes to mind is, show me the papers. Yeah, it's sad, but it's a reality in the academic field. So naturally, I started to play the publication game as well. So we call this a game because it's like a race with everyone else. So how many papers you got? And somebody will tell the numbers. How many papers you got? So it's like a game. So I started to play the game, and within this few years, I've also started to publish aggressively with my co-authors on the various in various high impact journals, including Nature. I've had paper in IEEE Transactions and Elsevier, and so on and so forth. So the epiphany to this came like this year. So this year was the year that I finally finished my PhD, and it was also during the time where we had some MCO. I don't know which phase of that MCO was, but it was during the MCO, and I had a lot of spare time. And it was during that time that I started asking myself, so I've published so many papers in, deep learning, in numbers of conference and in high impact journals. So what exactly is the impact that I have in the field? People would expect, someone who's published like me to have a high impact. And I tried to find the answer, but you know what? I had a hard time finding an answer. Actually, even though I have papers in publications in deep learning, but I don't think they are as impactful as I like them to be. So then that was the reason I decided to dig deeper into this problem. Is it Is it only my problem? Am I the only researcher in deep learning who feels this way or not? And I found the answer. And that's the reason I'm giving this sharing today. It's not. I'm not the only person, the only researcher who feels this way in deep learning. And the reason why is I came across this survey recently. So this is the gap that people in deep learning, they don't talk about very much. And that is 85% of machine learning / deep learning models, they don't actually make it into production. Yeah, this is a very recent survey by Gartner. And this number is a rough estimate, but it's the real number behind this is likely higher than that. And this survey came to me as a shock. Like, oh, I didn't actually believe it when the moment I saw this number. I did so much work in deep learning. Everyone did so much work in deep learning. There's like tons of paper in deep learning, but yet 85% of them don't actually make it into production. So where exactly do they exist? Yes, they exist on papers. They exist in publications. They exist in some obscure notebook that nobody will ever use or ever discover. That is the problem that we are facing right now in deep learning. A lot of the things are in theory. A lot of the things exist outside of the production environment, and a lot of things don't really translate to the industry, right? So that is the gap that we are talking about, and it's a lot to do with academic versus industry gap. And I don't want to go deep into this because I know it will bore some of you. But yeah, this is the issue that we are facing. We are spending a lot of time on practical, on theory part, not enough time on practical part. We are spending a lot of time on the research part, and we are not spending a lot of time on the deployment part. And we're also spending a lot of time training the model, but not so much time serving the model. We're spending a lot of time, talking about the novelty of the model, how this model is new, is useful, and it's the best thing. But we don't spend enough time talking about what's the practical use of this model. How can I use this in some company situation to solve some real world problem? That this is not talked enough in this industry. Yeah. So that is why the reason why I arrived at this talk today. So this is the gap that I was talking about over here. So in the red circle over here, this is by the way, this is a diagram by this very credible author. His name is D. Scully, and in his publication, this is something that he highlighted in this publication. In a machine learning / deep learning production environment, the code that involves machine learning probably involves a very, very small portion. And that is the one that you're seeing over here in the red circle. And a majority of that will probably involve other things than other parts of the pipeline, including, collecting the data, configuring your machines, doing some feature extraction, doing some evaluation, analyzing your results, serving your model, monitoring your models, so on and so forth. This field, this deployment deep learning field is still at a very early stage, and this field is very big. And the thing that we usually see in blog posts or in articles, like people start training model and then showing to the rest of the world, it's probably just the thing in the red circle over here. That is the machine learning code. Yeah, this is the deep gap in this field right now. Right. So after going through like a few resources, I find that out of all of this, wait, can I annotate on screen? Yeah, out of all of this, out of everything here, we can actually categorize this into like three major buckets. So 3 buckets, and those buckets are the data buckets, the data bucket, where we deal mostly with the data. And for example, we have like collection, labeling, all those are under data, versioning of the data, exploring your data, and storing your data. So those are in this data bucket. And the thing that we are most familiar with is the training/evaluation bucket. That is when you download your TensorFlow or your PyTorch library, and then you start training your model. So that's the the sexy part of deep learning. People like to do that, like to learn that, and people like to show off. Oh, I trained my model. And so that's the part that I think if you're in deep learning, you'll be very, very familiar with. And the last bucket, which is over here, this is the deployment side. And the deployment side is relatively young, in my opinion, this view, because there are a lot of space for improvement. There are a lot of space where people can make new inventions and new discovery. So I'll talk a little bit on all that. Cool. So let's get back over here. Okay, so this was the diagram I wanted to show earlier, but I didn't want to overwhelm you with all the tools that we have in deep learning. So this was the three main bucket that I showed you earlier. So we have the data bucket, we have this training/evaluation, and we have the deployment bucket. Okay, so I'm not even sure myself. I've been in this field for about 10 years right now, and I'm not even sure if I know every single thing on this diagram. And this diagram is constantly changing. So this is last year's one, 2021. And there are a lot of opportunities in all of these three buckets. Yeah, and probably we are most familiar with this bucket if you are into deep learning. So, and the one that's less talked about is over here, which is the deployment side of things. Cool. Right, so that is my brief introduction on what are we going to talk about. Deep gap, we've talked about what are the opportunities and why is deep learning, it's 2022 right now. Deep learning has been here for a decade or more right now. And why are we still here? And the reason is because of the gap that I talked about just now. And so far, do you guys have any questions that you guys want to know before we walk through some of my recent practical projects? Anyone, if you have any questions?
So far, no questions.
Okay. So if you have any questions, you can type it in the chat. If you feel like you don't feel like speaking it out, I'll constantly monitor the chat. Okay, so this is the second half of my presentation today, and frankly, this is the meat of my presentation today. I'd like this presentation to be much more casual, and I'd like also this presentation to be much more practical. And I really hope that you guys will be able to take something out of the projects that I'll be discussing today, and probably implement it on your own side projects, or as a hobby, or as something that you try out during your free time. Okay, so I'll talk about deployment, and there's two types of deployment in deep learning. So the two major types are, one is called cloud deployment, and number two is called the edge deployment. So cloud deployment is when you have your deep learning, your model, we call it, your deep learning model, stored in the cloud. So in the cloud means in a server, in a computer that is elsewhere, for example, in Google or in Microsoft or somewhere else. So whenever you have a device, so this device will talk to the server. So this is what we call cloud deployment. And for edge deployment, it is when your model doesn't live in some other servers in Google, Microsoft, but the model, your deep learning model, lives on your device, for example, in your phone or on your computer. And every time you want to make a prediction with your model, so you just have to talk to the computer instead of you having to talk to a cloud server somewhere outside of your home. Cool. So I'll talk a little bit on these two sides, and let's just go through the first one, the cloud deployment. Right. So in this cloud deployment, I'd like to talk about one of my very recent projects where I use deep learning. So I train a deep learning model, and I put the model somewhere in the cloud, and I have my mobile phone, and I use my mobile phone to take a picture of something and send that picture to the cloud, and that cloud will process it and return me the result. So this is what I am going to talk about here, deep learning and putting deep learning on Android. But we are going to use the cloud deployment approach. So in this example, this is the problem that I was trying to solve when I was getting started. So in this picture, you are seeing a picture taken from a microscope. Okay, so in this microscope picture, what you're seeing over here are picture of cells. So these cells are called microalgae cells. So what happens in biology lab is that people needs to constantly sample these cells from nearby, ponds or ponds maybe, and they need to count the number of cells that is on this image. Okay, so counting the number of cells in this image is a painful process. So imagine, you can already see how many of this is in one image, and we're talking about maybe hundreds or thousands of this kind of images. I don't know how many eyes you guys got, but as a human being, it's pretty tiring to just look at this microscope. No matter how many people does it, like it's going to be very hard to stay for a long time in front under looking at pictures and counting cells. Okay, so the current solution is we use humans in many labs. Of course, advanced lab, they have their own solutions, but majority humans are the one doing the counting. And instantly, when someone came to me with this problem and asking me, so can we solve this with deep learning? And I instantly say yes. This is somewhat easy to solve in deep learning because this is a very common problem in deep learning. So in deep learning, we call this an object detection problem. So an object detection means that you give somebody an image, you give this model, you give it an image, this model is able to tell you what is in that image and where is in the position of that object in this image. So it's relatively easy to solve in deep learning. So I'll talk about how I train a state-of-the-art model using Ice Vision, a framework that I've been developing with a few of my friends. And also the second part is I'll talk about how exactly I put this model and deploy it on an Android with a cloud deployment technique. Right, so the first part in any deep learning workflow is labeling. So this is the part where you collect a lot of the images and you need to start to label the image with bounding box. So the thing that you are seeing over here is that I took a lot of sample. I took 17 of these images from the collaborator from the lab, and I start to label them using this labeling tool called Label.ing. So this is a free and open source tool that lets you label pretty much any object. You can use it to label people, bicycle, cars, whatever. So in this example, I'm going to label the microalgae. So if you're not familiar, in deep learning, it doesn't work like magic. Like you don't just give it a bunch of images and expect it to tell you what is in that image instantly. So you got to teach that model, you got to teach that this deep learning thing to know what is what, So right here in this labeling, I am teaching this model how to recognize if something is a cell. So the way we do it is labeling. Okay, so for every images, what I do is I surround this cell with bounding boxes. So over here you see that this square boxes, those are bounding boxes. I do that for all of the images that I have. And once I am done doing that, then we will start doing what we call the training. So training is when you take your images that is already labeled with the bounding box. So we put these images and labels through a training system. And this training system will learn from the images that you provided to them. Oh, like this is this is the image of a cell, and where the position is the cell of the cell. So the system will learn through the examples that you gave it. So the system that I use, or should I say the library that I use for training, is this library that I am a core developer of. This Ice Vision library. So Ice Vision library is a super simple library to use, especially if you are getting started. So the codes that I am showing you on the right over here, these are all the codes that I used to train this model. So if you count the number of lines, there are a total of just 17 lines. And with 17 lines, we can have a model that is able to recognize cells, microalgae cells. And you can take the same code and change the data. And let's say you don't want to do microalgae cells, you want to do blood cell. You can do that for blood cell. The code will be the same. You just change the data, it will work on blood cell right now. So that's how easy it is to use Ice Vision. So all you have to do is just get this code. So I'll just briefly explain what these codes are doing over here. So the first line is the import. We import all the necessary libraries. And over here in this line over here, what we're doing is that we are reading the images. So I'm reading the images and also reading the labels. So remember, we did the bounding box label just now. So we are reading that into using this line of code. And over here, we are also dividing them into training and validation part of the data. So in deep learning or in machine learning in general, we want the way we train things is that we don't train it everything on one single source of data. We separate it into two sources. Okay, so we call them train and validation. And of course, also over here, we can specify the image size, which is 640. And over here, what I'm doing is I'm specifying the transformation that I run with this training. So in deep learning, there is a technique that is called image augmentation, or more generally, data augmentation. So the data that you see just now, I labeled 17 images. And in reality, 17 images, they are not enough to train a deep learning model. So usually we'll need in the range of thousands of images to get a model working well. So what we are doing over here is we are trying to augment the image. So out of the 17 images that I had just now, can I replicate or duplicate some of that images with some variations in between so that this model gets to see more images? So let's say, I have these images of this algae cells just now. Can I like rotate that images a little bit? Can I flip that images a little bit? Yeah. So we do all this kind of operations, flipping and rotating and maybe changing the brightness so that there'll be more variations of the pictures that this system, this deep learning gets to see. Okay, remember it learns from the example. So the more example that you give it, then the better your model is going to be. So over here, what we are doing is we are changing, we're augmenting the data so that it's instead of 17 images, it becomes thousands. Okay, so over here is a train and validation data set, right? And this portion over here is the portion where we define what is the model that we are trying to use. So in deep learning and in object detection only, there are already like hundreds, if not thousands of models. Each one has got their own advantage and disadvantage. And I don't want to go deeply into which one is good and which one is bad. And you probably have a good idea already if you're in if you're doing object detection. And the model that I will go to every single time I start is this model called VFNet. It's a model that have been giving me good results every time I train it. So I'm just going to stick with this model. And then next, I'm going to make it into a data loader, right? And next over here, what we are doing is that now we are going to train this for 10 iterations. Okay, so we're going to train this for 10 iterations, and then over here we're just showing the result. Okay, so here's what the training looks like. So this is what you will see on the screen if you start to train. And this training, surprisingly, took only 1 minute. So you can see over here is under 1 minute, and I've only trained it for 11 iterations. Okay, and of course I'm training this on my GPU. So the one GPU that I have is a 3090 GPU. Is considered quite a good GPU for training. But even if you were to use something like less fancy, like a 1080 or 1080 Ti, it will take roughly the same amount of time. And the thing is, with other frameworks, it will usually take a lot more time. So I've tried the same problem using other frameworks like YOLO or YOLO v5, or it usually takes a lot of time. And this is what I like about this Ice Vision. It takes like super quick that super quick iteration time. This allows you to like iterate a lot more faster. And I cannot imagine, iterating on this 1 minute versus iterating, with 30 minutes or more. So Ice Vision is actually built on top of a library called FastAI. So if you haven't done deep learning before, I will highly recommend that you start out with FastAI. So FastAI is a free course. You can just go to YouTube, you can search for FastAI. And the instructor is Jeremy Howard. So he's got a lot of video on how to use FastAI. And they've also got a very helpful, very good community around deep learning. And the thing that's different, a little bit promotion over here with FastAI. I'm not affiliated with FastAI, by the way. I just have a very good experience with FastAI, so that's why I'm talking about it. And knowing that like half of you like haven't really have no experience with deep learning, so I highly encourage you guys check this out. FastAI, check out their free course, check out their forum. And the philosophy that makes me like FastAI is that you don't need a lot of theory to get started. So the philosophy behind FastAI is a top-down learning approach, in a sense that you learn by doing and you learn by training your own deep learning model. So in the first class on the FastAI course, you are already training a model, and that is not like a toy model. It's a state-of-the-art model. It's a model that does extremely well already. Okay, and that is the learning philosophy behind FastAI. And a lot of students in FastAI, they are not even doing computer science. A lot of them, they are like day job as a dancer, and day job as a teacher, day job as a salesperson, maybe. And like after a few months into the FastAI course, or maybe some of them years, they are confident enough to jump into the deep learning field, and they even got a job. Many of them actually got a job because of the FastAI course. So if you're starting out with deep learning, you want to break into this field, FastAI, I highly recommend it. Go check out their stuff. It's free. They don't charge for anything, and they have a very good community. Right. So deep learning and FastAI and Ice Vision is built on top of this FastAI, and they already have a lot of good practices built into their library. So with very minimal tuning, you will get a very good model just to start with. Cool. And yeah, so let's get back to our example over here. So once we're done with training this AI, so what we have is a model that can now recognize cells from a microscope images. Okay, so this is like a brand new image that I give to this model, deep learning model. And right now, this deep learning model is able to tell me, so which portion of this is actually a cell, and it's going to draw the bounding box on it in the same way that I drew the bounding box for my data. So it's just replicating what I did over there. And right, so, and for this, this process just took the model maybe a fraction of a second, maybe less than 1 second to come up with this number. There's actually 29 on these images. And if, I can imagine if I start counting, it will not take me 1 second. It'd take me probably 1 minute to count all the single cells on this microscope image. So this is how much of a difference this model can make to someone's life who is, poorly counting these cells in some lab. Okay, and this system doesn't even need to rest. And like, human beings make mistakes, but models make mistakes too. But the chances of it can be reduced very significantly if you know how to do it. All right, so these are the codes that are used for this inference, and you can definitely check out the details on my blog post, and you can just run this on your own images, on your own data set that you like. Right, so that is the training part, the modeling part and step. So how exactly, like we take this model and share it with someone. So until this point of time, this is the least sexy part that people don't like to talk about. Most of the tutorials that we see online, it will end right here, right now. So how does this going to change someone else's life out in the open? We have lesser of that. And I'm going to show you here. You can easily take freely available systems and put this model on that and share it with anyone. Okay, so this tool that I'll be talking is the Hugging Face tool. So Hugging Face is a company that provides free service, including like training machine learning models and also deploying machine learning models. So if you go to Hugging Face and if you go to this link over here, let me just quickly go through that link and I'll show you how it's very interesting actually. If you go to this link, just copy Hugging Face Spaces. I'm in Hugging Face Spaces website right now. Do you guys see the website or you guys still see my presentation?
We can see the website.
Okay, right, thank you. So on this website, what we can do is that we can put our model and we can share this model with anyone in the world. Okay, so so I'm just gonna go through like a few, like a famous one. So let's go through this one. This one's quite famous recently. So what this model does is that it will take an image and then it will transform this image into like a cartoonish style. Okay, right, like that. And the way we do this is, you know, there is like a code behind this that's working, but the beauty is that we can share this link to anyone and anyone can use. So what I'm trying to show you guys here is that we can take our model that can count cells and put it on this website and share this with anyone else. So I've actually got that one already. So let's see how it's done over here. So this is my space. So this is the model, and this is how it would look like on Hugging Face Space. So this is the model, and I can click on this, and I can submit this, and this will then run the model in the cloud. So this is what we mean by cloud deployment. So it will start to calculate, and it will run the model, and then it will just give out an answer over here. And the count over here is that 68. So we have 68 approximately number of cells on these images. Okay, so we can do the same thing. And I can share this link with anyone else in the world, and you know, it can already make a difference over here, right? And the thing is, this is free. The service by Hugging Face is free. Anyone can go into Hugging Face and create an account, and anyone can upload a model on Hugging Face. So I'm going to show you guys how we do this over here very quickly. Okay, so and the good thing about Hugging Face is that when we put this on their website, we have an access to something we call the endpoint. Okay, so the endpoint of the model. So if you're familiar with the endpoint, so endpoint is that is like a third party that that translates that helps helps one application talk to another application. So for example, I want this model to be on an Android phone. So I can, instead of putting the model on Android, I can just use the Android phone, call this endpoint, and then this endpoint will go to the cloud and it will return the results onto my Android phone. So this is how I deploy my model on the Android. So if let's just go back over here to my space. So if I'm not sure if you guys can see this, let me adjust it a little bit more. Okay, so at the bottom of this page over here, if you click on View the API, so you would instantly see that for every model that is put on Hugging Face, it has an API endpoint. So this API endpoint is the secret to deploying on any device. So all we need to do to deploy on like a remote device or edge device is just call the API endpoint. So in Python, this is what this is the code that you need in Python, and if you want to do it in Perl, like this is as easy as a few lines of code. Okay, and of course, in other languages, you have your own method of calling the API endpoint, but this is fairly common in, I think, many languages. You have your ways of calling an API endpoint. So in Python, we use request. Cool. So this was what I used to deploy the model onto my Android phone. So this is the architecture of the deployment. This inference server is Hugging Face, and I have my mobile device that is going to talk to Hugging Face using the API endpoint. Okay, so this is the endpoint, and we're gonna and I can be at behind the scenes, training a new model and uploading it to the Hugging Face server without actually affecting the user's API endpoint. Okay, so that is something very, very good and something that I like about Hugging Face and the APIs. Cool. So this will be my Flutter app. So I use a framework by Google called Flutter, and so I quickly coded up a quick interface as a demo that loads up a few of these sample images up here, and when the user clicks on that, and this will launch the API. This will call the API, and this will talk to the Hugging Face server, and then the server will return the results when the process is done. And the beauty is that I don't even have to take a lot of space on my mobile phone because everything else lives in the cloud and everything is not processed locally, and the app is very small, and the model is a sophisticated model, and that is a very big, and usually it's very hard to deploy it on a mobile phone. Okay, so that is the advantage of using cloud deployment. So yeah, that is for my cloud deployment example. Is there any questions at all that's related that you guys want to know about this this method that I'm using?
So there's one question. Are all deep learning model neural network? So what kind of neural network is your eyes vision based on?
Oh, okay. Thank you for that. So in eyes vision, we focus on neural networks that does things related to computer vision. So computer vision means we deal with images, and specifically in computer vision, there are a lot of subtasks as well. So we have object classification, and we have object detection, we have object segmentation, and so many others. So eyes vision deals particularly well with object detection. So object detection is when you give an image and the model is able to draw boxes around the objects in that images. So the models that exist in eyes vision, they are mostly models for object detection. So for object classification, you have like other models. And for object segmentation, you also have other models. They are not 100% the same, but some parts of it might be similar. Is that does that answer the question? Is that in eyes vision? In eyes vision, I think we deal with deep learning models only. So you might wonder. I mean, deep learning is you might heard about the neural networks, right? So if you use things like if you use softwares like MATLAB, so you might see this term like neural network, or in older software they call it neural network. So nowadays neural network is it's still there, but it's deep learning is maybe a subset of neural network, the way I understand it. So neural network is a shallow version of deep learning. So in eyes vision, we deal with deep learning models most of the time. We don't have neural networks or shallow models in eyes vision. Is there any other question?
Yeah, so I think there's one question about cost of cloud deployment. So do you know how much of cost to deploy a complete data pipeline can be costly?
Okay. Yeah. So I'll just talk on what I know. With Hugging Face, the thing that I just showed you just now, they are free of charge. Like there's no limitation of the number of inference that you can make on this, and and they don't charge for individuals. They do charge for company, but they don't charge for individuals. But the caveat is that, you know, this thing that I am showing here, it may not be ideal for certain situations, especially if your user base is like many. If you have thousands of requests suddenly coming in, so this will not work. And you will, for that, you will need like some more advanced cloud deployment techniques, and those will probably incur more charges. And you start seeing things like Docker, and you use like Kubernetes in the clouds. And so you have like things like AWS, Amazon, who provides these services, and the cost, from what I understand, may vary. So it may vary on how much compute power and how long do you use it, and how many users, and so on and so forth. Yeah.
Okay, there's another question. Do you have any recommendation on integrating cameras on desktop robotic arm to do the training and inferencing?
What do you mean by integrating camera? Like, you mean running the inference on the camera?
I think so.
So if you want to run an inference on the camera, yes, you can. Technically, it is still an image, so you can take the camera image and send it to Hugging Face, and it will still do the inference for you. Yeah. So instead of like over here, right? Instead of dropping an image, I can use the webcam and just take a snapshot of my webcam, and it will still work. Right. So let's say you have a phone camera and you took a phone camera of the cells, and then the cells and send it over here, like it will still work. So if you want inference on a camera in real time, so that is something that I'm going to talk about like after this, if you have enough time.
Okay, there's two more questions. I think you just answered these two questions and you just continue your presentation. Okay, so one of the questions is, do you need to label one by one all your images? How about if it's a huge labeling? So if the question is, if you have a huge data to label, do you need to label one by one, or there's a way to label huge labeling?
Okay, so that's a brilliant question. So the thing that you might notice is that, yeah, labeling data is painful. It's the most painful, it's the most time-consuming thing in deep learning. So do you have to label one by one? Unfortunately, yes. If you have a picture and out of the 10 cells, you just label 2 or 3, then that means the model is not going to properly learn how to detect the cells. And if you give it like a picture, it will just maybe detect 2 or 3 cells from the image if you don't label everything. So you have to, labeling is probably the most important part of the entire pipeline, and you got to label it. You can label every one of them as best as you can. So the good news is that there are currently a lot of tools out there that helps in labeling. So there are tools out there that can use AI-assisted labeling. So AI-assisted labeling means that you have like a labeling tool, and this labeling tool will suggest labels and boxes to you, and all you have to do is just confirm them by clicking and a few clicks, and you're done. And doing this, I think using this kind of tools out there, and some of them are free, it can significantly speed up your labeling process.
Yeah, so I can add on to that. So now there's a movement. So people saying that last time people all focus on models, so we have model centric. Now people are more focusing on the labeling part, which is the data centric. So if you're interested, you can read about that from Andrew Ng. He talked about all this data centric model. The last question is before we move on. So does the Ice Vision work on Windows or Windows subsystem for Linux?
Oh, so at the moment, we don't. It won't work on Windows. It works on Linux. So if you can get a Ubuntu machine, it'll be best. Otherwise, WSL works just fine.
Okay, so I think you continue first. We have a few more questions later. You can.
Okay, sure. Okay, right. Do we have a time limit? I'm sorry.
Yeah, the original time is supposed to be 1 hour.
yeah. That I was concerned about that. So I thought, is it okay if I proceed on?
Yeah, I mean let's make it to 9:30 then.
Okay, so I'll try my best to give you guys what I can, and at the same time not just brushing through the surface. Okay, so you can read more of this on my blog, by the way. If you want to experiment this yourself, feel free to do so. And I've also used the same technique to deploy language model on Telegram bots. So yeah, so in this project, what I did was I took a language model. If you're not familiar with, a language model is a model that's trained on languages. It can be English, Malay, or so. This language model has got many tasks as well. It can classify whether a sentence is positive versus negative. It can write an essay for you, or it can do like some other stuff like fill in the blanks on the missing words in the sentence and so on. So these are language models. So what I did in this project is that I used the same principles that I used in the previous project just now. I use Hugging Face, and they have language models that is available for free on Hugging Face. You can just use the API call, and you can get you can call a language model, send it a sentence, and it will give back the answer to you with just a few lines of code. So this is what I did over here. I used the freely available language model on Hugging Face, and I use the API, and I integrate it with a Telegram bot. So that's the idea over here. So at the end of the day, I have like a Telegram bot over here. Let me just show you the outcome. So this is the outcome on the right. You see, so over here, you'd see I have a Telegram bot that is able to complete your sentence. So I can send it a text, hello there, and then it will send an API call to the language model at Hugging Face, and it will try to complete your sentence based on what it learns from the language that it's trained on. So how I did that, it's using the same steps. So maybe I won't go in as much detail over here because of the time limitation. The details are in my blog post, and the principles are still the same. And the different thing over here is that I'm using a Telegram bot library that's in Python, and integrating the API call into this Python Telegram bot library. And so the thing that you can do with this is that there are literally hundreds or not thousands of language models on Hugging Face that's available for anyone to use, and they are trained on various tasks. Some are very interesting. Some can tell you whether like like a movie from a movie rating from a movie, whether its rating is good or bad, or you can even write out a movie rating, an essay for you, or things like that. There's so many interesting models, and you get if you have the time, I highly encourage you guys try it out. And these are not toy models. If you guys notice, GPT-J is one of the most advanced language models known today, and so it'll be really cool, like knowing that you have access to this for free. Yeah, so that is yeah, probably. So probably yeah, those are the two recent projects that I talk about on cloud deployment. And right now, so I'll talk a little bit more on the other side of the deployment, which is called the edge deployment. So in cloud deployment, the model lives in the cloud somewhere in a remote place. So in edge deployment, it is different. The model lives on your device. So for example, if I have a phone, then the model is inside my phone, and I can run an inference on my phone. Okay, so that's the difference over here. So this is one of my recent projects. I ran an inference on my computer on using it's still object detection, but this time I use a different library. And so the catch over here is that I'm able to run this at a very, very high speeds on a CPU. So which is pretty much unheard of in the world of deep learning. It's very, very hard to run 50 frames per second on a CPU, especially for object detection. So yeah, so what is the motivation behind this? So the motivation over here is that I was talking to a friend, and this friend was trying to train a model that can detect the license plate. So Malaysia's license plate over here. So I instantly thought that this is something easy that deep learning can do. All we need is data. So I decided that, okay, I'm just going to use a different library this time. It's not Ice Vision. I use a library called YOLOX. YOLOX is a library. It's also the name of a model. So I managed to train this YOLOX model, and that's the good news. And the bad news is that it's what you see over here. It's extremely slow. Like you can imagine, right? Putting this on an RFID toll in Malaysia, what would happen? It's not going to be good. RFID is supposed to be fast, right? And we don't want things to go slow on RFID lanes. So not cool. I'm not sure what systems are they using. Okay, I'm not here to speculate. So the bad news is that with YOLOX, YOLOX is one of the latest model. It's one of the state of the art. It just could not run on CPUs. But then you might ask me, oh, why not run it on GPUs then? So GPUs is graphical processing unit or graphics card. If you're not familiar with, deep learning models perform well when they are run on graphics card. So not everyone has graphics card, and graphics card are not cheap. The one that I'm using, they probably cost like 10K right now. So not everyone, not every company, not everyone is willing to invest graphic card on deep learning task, right? So, but everyone has computers. Everyone has Intel i5, for example, like relatively cheap. Intel i5 cost an old version costs like less than 1,000 ringgit, probably. So the problem is, can we run deep learning on an old Intel i5? Yeah, that is the problem over here. And for most cases, we cannot. If we try to, it will result in things like this, very, very slow. So in this blog post, I'm going to show you how I optimize my model so that it's able to run on conventional CPUs at very, very high speeds. And the final number that I got was 50 frames per second, which is insanely fast. So the workflow is still the same. I collected a bunch of car plate picture. I just walked through my neighborhood and collected a few of them, and I started to label them like one by one. So I collected for this blog post, I collected about maybe close to 100 images. And yes, I painstakingly label every single one of them. I spent like one afternoon to label them. So, and yeah. And once I trained the model, I export it to a format that's known as Onyx. So Onyx is slightly better compared to the first model, the first video that you saw just now, in the sense that it's slightly faster. Okay, but is there a better solution compared to Onyx? So yes, there is. And the better solution that I found is using a tool called Openvino. So this tool is by Intel, by the way, but they are making this tool open source and free. And the way we use this tool is very easy. It's just a couple of lines of installation and you're good to go. So Openvino is actually a tool developed by Intel to optimize deep learning to run on CPUs. So that you don't have to splurge a good amount of money to get a GPU so that you can run your deep learning model. So any relatively modern CPU can take deep learning nowadays with Openvino. So the way you install it is with this line, only one line, and the code below shows you how you optimize the model. So let's say let's suppose that you already have an Onyx model. So all you got to do in order to optimize that is just run this command, MO. MO stands for model optimizer, and you specify your Onyx model, and you specify a few more parameters, and just boom, your model is now optimized to run on CPU. Okay, so the first optimization that we are going to run over here is called the Fp16 optimization. So if you're familiar with Fp16, it's we call it half precision. And what it's doing is that it's changing the storage format of the model so that it doesn't store as much information as a previous one. So it stores half the information, half as accurate information. Okay, so that makes the model slightly less accurate, but it improves the speed of the model by a lot. So this is what I mean. So now we are beginning to see over here, we are seeing twice the speed of the original image, the original model just now, the very first video that I showed you just now. So it's at almost 20 frames per second at this format, Fp16 format. But as you can see, it's still, not very ideal. It's still kind of like stuck and laggy and slow. And definitely we don't want this to be on our toll booth in Malaysia. We already have enough trouble with that. So in Openvino, there is another technique that we can use that's called post-training optimization. So this is a technique that compresses the model format. So instead of Fp16, it uses an even less accurate format. So it's using a format known as INT8. So INT, integer 8 format. So the trade-off is that this is less accurate, but it supercharges the speed of the model to a great deal without sacrificing a lot of the accuracy. The accuracy would drop to a certain extent, but not much. And the outcome is that we can now run this model at very close to real life speed. And that is how I use Openvino to deploy my models on a CPU. So if you have a webcam, you can also use your webcam and channel your webcam to the Openvino model on the CPU, and it can also detect like number plates from your webcam if you want. Okay, if you train, of course, if you train it on if your data is doing some other types of objects, you'll detect the objects that you label on your data. Cool. So that is that is the edge deployment that I was going to talk about. I actually have the detail is in the blog post. If you want to try it out, go ahead and check out the blog post. And I recently also discovered an alternative to Openvino, which is called Deep Sparse. I find this very, very interesting because it can do even faster speeds. And just now, you've seen how it looks like to run at 50 FPS, right? With Deep Sparse, it is possible to go up to 180 plus FPS. So very, very fast model and running on CPU. And it's not fancy CPU, it's just an i5 CPU. So this is very attractive, and especially if you are in deep learning for some time already, this would be something very cool to explore. Right, so so let's just go to the takeaways. So if you're getting starting with deep learning, that is very good. I highly encourage you guys to start learning on how to train your models, how to label your models, but do not neglect the last part of the pipeline, which is the deployment side. Because most courses in deep learning that I see, they don't talk a lot about deployment. Things just end at the training, and things just end in the Colab notebook. So especially on tutorials. So start to ask questions on how do I actually deploy this model? Can I put it on the cloud? Can I put it on my Intel i5 MacBook CPU? Yeah. Can I put it on my mobile phone? Start asking questions like this, because these are the questions that academics like me, we don't like to hear these kind of questions. So we just want to put out the model and just forget it. But the reality is not like that. We need to have more people talking about deployment side, because this is the gap right now. Okay, the gap is on the deployment side. And of course, if you want to learn more about this, we have an entire new field, I'd say new field of ML Ops. So ML Ops deals with the deployment side of deep learning. And there are a lot of new tools, there are a lot of new exciting things in ML Ops, and the field is new. So there is no like one single way to do it. So that is something to take away. And the last takeaway that I want to show you guys today is that there are existing open source tools. Most of them are free, and you can use that and leverage that to deploy your deep learning model. Right. So I guess that will be my last slide today. Thank you very much. If you have questions, I'll be happy to answer them for you.
Yeah, so there was a question back to your microalgae detector just now. So they said you train with the image size of 680, isn't it?
640.
So 640. Okay, then when you do the inferencing, is the size important? Image size? What happens if you upload a bigger size? Will it work?
Yes, that's a very interesting question. The answer is the image size is important. So what you give it during the training is also, it must be the same as what you give it during your inference time. Yeah. So 640 during training, it must also be 640 during the inference time. Yeah.
Yeah. So that means that even you upload the larger size, it will actually resize back to 640, isn't it?
You have to do the resizing.
Yeah. I mean, at the back, you will actually resize back to, then only you do the inferencing.
Correct. Yeah.
Okay, so there's one question, the student from, I think, UTHM. So he's doing FIP. So do you have any reference material for this object detection using YOLO 5?
YOLO 5, if you go to GitHub, YOLO v5 by Ultralytics, there are already a ton of references over there. Yeah, even if you Google YOLO v5, the first result would be from GitHub. And yeah, there are already a lot of resources over there. If you don't like GitHub, you just go to YouTube, and yeah, there are a ton of video on YouTube on YOLO v5.
Yep. So I think we cover all the questions. If anyone have any more questions, you can put a chat, or you can just open your mic and ask if you don't want to type.
Yeah.
Then talking about the ML ops. Yeah, I think it's a very hot topic. I also given a few talks to universities and even master students. ML is a very hot topic because when you you just talk about deployment, most of university also don't teach about deployment, and then ML ops is one of the things that is being practiced by many corporations nowadays. And it's a skill set that not many people actually know, because it's actually a best practice as how do you deploy a machine learning model, then how do you monitor the model, and then how do you go back and improve and retrain the model. Those are the things that a lot of universities or a lot of people even working in the industry doesn't have a good best practice. So learning this or getting know this ML is definitely something that most of the company are actually looking for.
Absolutely. Yep.
So there's one question. Is it better to implement YOLO or CNN on computer vision project?
Sorry?
Is it better to implement YOLO or CNN on a computer vision project? I think it's a different functionality. So maybe you can explain that.
Oh, okay. So yeah, actually right now in computer vision, it is very hard to say that this model is the best and that model is the best and this model is better and that model is better. So even if somebody is able to say that, few weeks down the line, there will be a newer model that is better that compared to the other model. So the best way I see to decide on this kind of things is to see what's your use case. Okay, for example, like for YOLO, right? So for YOLO, what the advantage of having YOLO is that it is relatively lightweight and fast compared to other CNN models. Like, okay, so if you talk about, like, there are a ton of other models that has better performance than YOLO, like accuracy wise is better than YOLO, but it's very slow. YOLO has lesser accuracy in a sense, but it is lightning fast compared to other models. So if you ask which one is better, it really depends on your use case. So if you're working in a situation where your accuracy is the top priority and you don't care if the model is slow, then you probably don't need YOLO. But if you're like operating like a real-time situation, like a toll booth or something, you probably want it to be fast enough so that people don't have to wait and things don't pile up and stuff like that. But I understand this question, especially if you're starting out. You might think, which path should I go? I would suggest that just start with the simpler ones. YOLO, I'd say YOLO nowadays, it's become very simple to get started. All you got to do is just go to YOLO v5 webpage. With one installation line, you will get your YOLO v5 running already. And once you try a couple of those models and you see what are the differences, then you can judge for yourself what is good for your application. Okay, so today I've shown you two models. In the first example, I show you VFNet. That model is very, very accurate, but it is also slow. The second model is the YOLO model. So YOLO model is less accurate and it is quick. So notice that I apply it at the different cases also. So if I were to use VFNet for my real-time detection on the webcam, it will probably, you know, it will probably be super, super slow. You have to wait a long time. Not ideal. So yeah, so it's going by case. If you're thinking which one to start, go with the whatever easiest one you can find. I would recommend going with YOLO V5 because I think it's very easy to get started with.
Okay.
Yeah.
So I think, Quadri, Wasim, you asked a question there. The session is recorded. If you want to watch the recording, you can go to our TensorFlow Facebook page, which I posted on the top. Join the page, then you can actually see the recording. Okay, so everyone that attended the session, I appreciate that if you go and fill out the question form, survey form, leave your comment or feedback. So at least in the future, we can actually, cater more event for you. I just one thing that Dixon, I just to tell you that last week we have a talk by Intel on the Openvino, and today you talk about Openvino.
Oh wow, that is I missed that then. Oh man.
So it sounded like I'm promoting Openvino. The two back-to-back speakers talking about Openvino.
Oh, cool.
Okay, I think that's all. If you guys, I already also share Dixon LinkedIn and also his blog post and his personal, his GitHub page. So if you want, you can connect to him on his LinkedIn page and also find all the writing on his blog post, the website dixonjo.com, and also you can look for all the things that I have done in the GitHub page. If you have not seen it, I can share it again in the chat. Yeah, so again, before you go, please click on the survey to fill out the comments and feedback so we can actually manage or organize more events in the future. So for information, I'm also going to organize a machine learning study jam where we are going to do 4 weeks consecutively, face-to-face physical to learn about Python programming, machine learning, all the way to deep learning. Yeah. Look out for that. We will announce that soon. Okay, so with that, thank you very much, Dixon, for your fruitful, insightful sharing presentation today. So for the rest, we hope that you still join. Look out for all the announcements and all the events that we are going to pair up for you in the coming future in our TensorFlow Deep Learning Malaysia Facebook page. Then thank you, everyone, and have a good day. Bye-bye.
Bye.